everyone. My name is Brad Brown. I am an instructor with WebAge Solutions, and I'm also an independent practitioner. Many of the people that WebAge uses for course delivery and webinar delivery are not professional instructors. Hopefully we're good at what we do, but we're actually practitioners in the field. So I consider myself a solution architect first and enterprise architect, and most of what I do is solution and enterprise architecture. And spend about 30% of my time with course delivery as well on a number of topics related to architecture, agile software delivery, and tooling. By way of background, most of my career has been with Loblaws. At least some people will know who Loblaws is. And as the largest grocery retailer in Canada, I had the chance to do basically everything there is to do in IT there in almost 20 years there, starting from writing code to running software development teams to running some big projects like Y2K elimination, introduction of financial services, and we did our first direct-to-home delivery service way back, but before that was really fashionable. So I have a perspective on architecture and enterprises that's pretty broad and in a few cases pretty deep. I've been independent for not quite 15 years now. And in that time, I've held CIO and CTO positions and interim basis for smaller organizations. But again, most of what I do is solution and enterprise architecture most of the time. And that's really where my passion is. And that really informs a lot of the material that's in this talk, because what we do in architecture has really been affected and also affects what we do in software development and with agile software development practices. And that's what we'd like to talk about today. Agile architecture for a more agile scaled architecture framework. And as I say it, I realize that's a little bit of a tortured title. But what it's trying to capture is the idea that we have agile software development practices. We're going to use Scaled Agile Framework or SAFe as an example. And architecture is two large concerns of enterprises in value delivery today. And agile methods and agile practices are affecting both. And what we're going to be looking at there, after I find my cursor, is a few things. We're going to look at the intersection of agile and architecture, and that slide says what can go wrong, but what I'm really looking at is where are some of those intersections and where do they apparently conflict? Because in kind of some classic paradigms, agile software development and architecture appear to have some conflicting objectives. But we're going to argue that that's not really true, that agile and development, architecture and development is really a win-win. They're really very synergistic, and I'm actually going to argue that they can't really get along well without each other. But that creates some different motivations, and we're going to look at the idea of intentional architecture and emergent design as two extremes in a spectrum of different ways that we can deliver architecture. And to make this a little bit more real and have some guidance on how you might actually realize our objectives, we'll look at architecture and the SAFe framework, Scaled Agile Framework. I'll talk about why when we get there. We're going to close with some observations about adapting the approach, because one size definitely does not fit all. During this, please feel free to drop a message in chat, and if there are questions, happy to address them. I'll address them at an appropriate point, so maybe not instantly, but definitely will get to questions. And I'll have some time for Q&A at the end. So let's begin with Agile and architecture together, with the observation that software development has really evolved over time. The graphic is an illustration of a waterfall methodology. And of course, nobody ever really did absolutely pure waterfall, but we used to be pretty waterfall based. We complete a phase before we moved on to something else. And what's been happening in the software development field for several decades now is a move to a more agile methodology, where instead of having to work out everything in one phase before we move on, again, that's a bit of an extreme, but we work in iterative sets of iterations. We develop their software iteratively over time. Well, architecture has needed to evolve as well and is evolving, but it's really challenging for architecture. See, back in the days of waterfall, it was kind of clear. We had architecture up front. We did it as a phase. And our definition of done, if I can borrow the phrase, for architecture was that we had developed the complete architecture for an entire system. So an architect's job was relatively well defined and could be relatively time bound. We had a phase of work to operate in, and we would go and we would develop an architecture and kind of metaphorically throw it over the cubicle wall to the next phase. But that doesn't really work anymore. And the challenges for architecture in an agile world are manyfold. Where does agile actually fit? How do we know when we're done? And if we develop architecture, we have challenges. If we do too much work up front before development really starts, we miss the opportunity to learn from the development process, from what's discovered during development. But if we don't do enough upfront, we don't provide enough direction to development teams. And it's almost like we didn't develop architecture at all. So the world that we have, that we face in an agile world can be quite challenging, particularly in organizations that really haven't yet determined how to merge agile and agile practices and the practice of architecture together. But we're going to argue that combining the practices of architecture and development is a real win-win. A solution that's been architected well tends to be robust. It's built to last. It's extensible. It provides a foundation for the future. And given the amount of investment that organizations make in developing new software or even customizing software that they've acquired from somewhere, building something that's going to be built to last is a really important property. It's something we really want to be able to achieve. On the other hand, agile software development gives us some significant benefits as well. It allows us to be much more responsive to evolving needs. And it also allows us to learn from the practice of actually doing. As we're building software, as we're going through sprints and developing interim features and looking at them and getting feedback, we learn. We learn about the business process. We learn about the solution space that we're trying to build for. We learn about our development team's capabilities. And this learning allows us to ultimately deliver a better product. So we see positive aspects from both architecture and software development. And ultimately, what we want out of a combination of the two is to be able to deliver the right system with the right features at the right time. And the last clause here, built to deliver value into the future, I think is the most important of these. And it's where the contribution of architecture and the application of architecture can really have a significant effect. But to give us some context to how architecture can contribute, we need to explore a couple of ideas, and that's intentional architecture and emergent design. Now, to some extent, these are a little bit jargony terms, but intentional architecture is generally taken to mean something along the lines of this definition. An intentional architecture is the design of the solution. Oh, sorry, I've got these backwards. So forgive me, I've got the couple things switched in the slide. An intentional architecture is the description on the right. It's a deliberate architecture that is determined largely before a system is built that development works to achieve. In other words, an intentional architecture is something that we come up with and then say, here's the thing that you want to build. Here's what I intend you to create. An emergent design, forgive me, flip the definitions. An emergent design, on the other hand, is the design of the solution that emerges little by little as the code's built in small increments. It's kind of what happens as you develop code, as you go through sprints and kind of create something. What's the design of the thing that you create? Well, if it emerges from the process of development, that's an emergent design. But I'm going to argue that neither of those is really particularly ideal. Emergent design is the design that you end up with as you build. That's not a good thing, probably not a good thing. Because if we just go through the process of building something, what we're essentially designing, the design that we end up with, is the design that happens to work for the path that we went through development that got us to that particular result. It's kind of happenstance. And it's probably going to work for now. It meets the requirements that we built for because, hey, that's what happens when you build. But it doesn't necessarily really have any kind of robust qualities. It could be that if we change something, it's going to be really hard to do, or a new requirement comes and we need to do a lot of refactoring, a lot of rework, because the design didn't anticipate those things. On the other hand, unintentional architecture, the architecture that is essentially the architecture that you thought was right before you built anything. And an intentional architecture, it suffers from exactly the same fallacies that we have in classic waterfall-based software development. The fallacy that we can actually think about, have complete knowledge of the future if we think hard enough. See, if I sit down and I try to develop the architecture of a complete solution, and I could kind of think through and I could say, well, I know what the what the solution needs to do, and I can figure out what I need to kind of all the pieces that put together. Great, that's really nice, but it's just what we thought before we built anything. Now, when we actually start to build things, well, we're going to discover things. We're going to discover things we didn't anticipate. That's part of the point of agile software development. Those things, by definition, weren't anticipated when we built that intentional architecture. Therefore, they missed. So whereas an emergent design might be just a little bit too loosey-goosey and kind of accidental, an intentional architecture might be too rigid and might be just assuming a future that isn't really appropriate. What we really need is elements of both. Intentional architecture provides an overall design that a project can work towards, that the development team can work for. It essentially provides a framework for development. If we have an intentional architecture, it's the guide that we can build towards as we're actually building our software. But in emergent design, well, that's kind of good too, because it gives us a way of adapting to changing needs. And I think more important, it makes use of learning that we achieve during the development process. And ultimately, what we really want is we want a balance between those things. We want those good positive aspects of both intentional architecture and emergent design. So how do we do that? And particularly, if we have an architecture practice, as a lot are, that really hasn't been integrated with agile software development yet, which is kind of thinking of the mindset that I'm here to produce architecture. I'm going to design the system, and then I'm done. Well, that doesn't fit this balancing act. Well, to be able to talk about that effectively, I need a little bit of a framework. So we're going to put this question aside a little bit and introduce the framework that we're going to be using in this discussion. And that's the Scaled Agile Framework. So the Scaled Agile Framework is one of many frameworks for doing agile software development. We use it as an example here because it's really popular. It's very widely used, either Scaled Agile Framework or just SAFe, or an adaptation of SAFe. In fact, to be honest, I've never worked with anybody who uses pure, complete SAFe. Everybody I've worked with has adapted SAFe to their needs, because SAFe is really intended to be adapted. Either you pare it down, use some elements, or you actually change it and adapt the parts that are kind of culturally inconsistent with your organization. But regardless, the kind of essentials of SAFe are pretty commonly used. And if your organization isn't using SAFe, it's using something else, well, you'll recognize that in the material that we're going to go through shortly. The piece that I'm really pulling out of SAFe is the bigger picture of how agile software works. I'm not terribly concerned with the details of what's going on during a sprint, but we'll get there. Now, I want to acknowledge that SAFe actually does have guidance for doing agile architecture. There's kind of a module of SAFe that talks about exactly this. And it doesn't talk about it in exactly the same way that I'm going to, but everything that I'm going to talk about is consistent with the way that SAFe talks about it. What I'm doing is illustrating a set of choices. And again, SAFe is intended to be adapted. And what I find with the discussion of agile architecture in SAFe framework itself is it's got a lot of really good general points. It doesn't necessarily tell you in great detail how to do things. So you end up making a bunch of choices like we're going to illustrate here. And given the size of SAFe, we're only going to look at parts that are relevant. And what is that? Well, we're going to start with a kind of overview of SAFe. This is right from the SAFe website. So this is the canonical view of the overview of all that's in SAFe. And what you'll see here is this is pretty big. SAFe really covers a really broad set of topics, broad set of concerns. It's not just about how development teams produce software. It's how organizations manage those teams and manage the value delivery process and think about kind of what things are going to come up and what the products they're developing, how they should evolve, and how they fit into business. Is really kind of very, very broad. And the parts that I want to focus in on here are just a couple of these. One is up here, it's part of the lean portfolio management stream. And that's about how you determine what it is that you're doing and kind of coordinate the activity. And you deliver the activity through the continuous delivery pipeline, or what a lot of people will call the Agile release train. Now, actually, the Agile release train is not the name of the whole process. It's the name of kind of the kind of structure of how this fits together. But often you'll see people talk about the Agile release train. Well, this is effectively what they're talking about. It's a mechanism for integrating the work of multiple delivery teams, the train, to deliver business value. And how do they do that? Well, and here's where it's going to start to get specific for our talk. Essentially, each development stream is following a path, and that path starts with an inception phase and then goes through a number of increments. And in these increments, each of the increments is an agile process. It's an iterative process. And the thing that I really want to point out here, the thing that I'm calling out here, because this is where it's an essential part of how we integrate architecture into this process, is the idea that we have an inception phase which is different from the increments. Each of the increments is, you could think of it as a release, would be a kind of decent way of thinking about it. An increment is something that produces software. The inception phase gets us ready to produce software. It's where we decide, well, now we're going to flesh out the project. We're going to determine what it is that we're doing. We're going to figure out kind of what it's all about. And that's part of where we link in architecture. So hold that thought. We're going to come back to this diagram, or variant of this diagram. But now that we have a little bit of a framework around what SAFe is, what SAFe is looking for, we can talk about what it is that an agile process needs from architecture. In other words, kind of why do we want to do this from the point of view of agile software development? Well, the first thing I'm going to argue is that we need some upfront architecture. It is necessary, in my opinion, in this framework, to develop an architecture before really starting to build. Now, how much of an architecture we'll get to in a moment, but the reasons why we need an architecture before we start to build are, well, legion. One of those is that reason that I mentioned before. It provides a framework and a roadmap for development. Once we actually start to get into development, those increments, and within each increment, the sprints, how do we know what to do, what to work on? Well, we could look at backlogs and we could make some decisions about what we're going to start on, sure. But having an architecture really helps that process because it gives us a sense of what the big picture is. Maybe not details, but the overall big picture. And that means we can make decisions in context. It makes it much easier to see which backlog items make sense to do before others. What are the key things? It also helps us make some decisions about build sequence. I might make a decision, for example, like I can identify from the architecture some parts of a system that are going to be relatively high risk because maybe they're complicated, or maybe it's something we haven't done before. They're deep integrations to something. There are lots of reasons why there might be risk. But if I can understand those, one of my decisions might be, well, I want to de-risk the overall project by exploring some of those high-risk things first. Maybe some of those high-risk things are so risky that we may not even be able to accomplish them. Well, if that's the case, I want to discover that early so we can terminate the project. Or maybe they're just things that I want to discover early so I can adapt to what I find out. Something was way more complicated than I thought, or maybe it's not. Or maybe what we want to do is we want to be able to deliver a number of things for a particular set of business functionality because we have a product plan and roadmap. And we determine this thing goes before something else in the product's release strategy. Well, the architecture helps us make the decisions about how to actually accomplish that because it makes it more apparent about what the components are, the parts of the architecture, and how they fit together. But the last point, the last bullet point here, I think is really, it's underappreciated, but it's the biggest value of having some architecture before you actually start to build. And that's that we can reduce rework later. Because what can easily happen is if we don't have an initial architecture, if we just kind of charge into development, no matter how thoughtful we are, it's not that uncommon to go down a path that later on we discover, we got to change something. Because we start to run into something and we didn't realize there was a connection between something, or we discover something new and we didn't kind of realize they fit together. Or we've built something for what we knew at the time. This is the most likely. We've built something for what we knew at the time back in an earlier sprint. And we just hadn't gotten to thinking about how it would affect something else. Having an architecture up front doesn't mean these things don't happen. It doesn't mean we won't make things that we have to reverse later. But it does make their occurrence much less likely. But having an architecture up front, or at least some upfront architecture, is not just for development. It has benefits for other things as well. So back in that inception phase, when we're organizing the project, having that initial architecture, it'll help understand what's feasible, what's not, what's the scope of the project, how big is it? And this, it doesn't solve, but it helps address one of the challenges that often comes up with management, IT management, in relation to agile software development. See, it's often hard to estimate how big something is. And it's often seen as kind of an anti-agile practice to try and estimate the size of something. Well, unfortunately, management really needs to at least have some sense of how big things are. And that problem tends to get solved as organizations get more used to applying agile practices and they get used to what their capabilities are. But it can really help to have a bit of upfront architecture, to have a good sense of what the scope of a system might be before you start, and to have at least better estimates. Now, I'm still really cynical about estimates, even if you really work up an architecture and spend a fair bit of time with it, really spend a lot of detail on estimation. Personally, I don't think it's possible to get within better than plus or minus 50% or so, no matter how much work you do up front, which has gotten me in conflict with my management from time to time. But I'm more comfortable having a good scope and sizing discussion with an architecture than without. Another reason an architecture can be really useful is it helps identify external dependencies. Now, sometimes these things are obvious. I'm working with a business partner. We have to do this to connect with them. Okay, that kind of thing can be obvious. But it becomes a little less obvious when you start to have things like, systems that expose a good API that other people may consume, systems that take advantage of external capabilities. Understanding those and identifying them is something that an architecture can usually develop with a little bit more precision than just discovering them along the way. And the last thing that an architecture can really help for that goes beyond development is it helps it helps people understand what resourcing is going to be required to complete a project. And that's things like development resources, how many people and things like that, but it's also skills. It's also around specific pieces of product knowledge, what it is that we're going to connect with, or kind of other things that might be involved. It's really associated with scope. So all these benefits of upfront architecture really give us the ability to start a project, start development in the right direction, give people good framework to work on, good guidance, guardrails, and help us make better decisions. Now, I've argued that some upfront architecture is needed. That word some, that's really kind of sticking out there. What do we actually mean by that? Well, I don't know exactly what we mean by that, but I know a little bit about what I want from my upfront architecture. I want an architecture that's just enough to support key business decisions, things like scope and viability and resourcing. Now, what's enough? Well, I don't know. It depends on the circumstances. But what I'd like is enough upfront architecture that it helps inform those decisions so that they can be made with a little bit more comfort. I want an architecture that's just enough to be an actionable framework for development. And what I mean by that is it's a framework that a development team can take in. They can actually start to use it, that it's meaningful for them, that it contributes value to the development process. But at the same time, I want to balance that. I want something that's not so much that I haven't put so much thought into the architecture, that I'm really prescribing things that a development team can figure out by themselves or for themselves. Because our intention here is not to step on the toes of designers, software engineers, developers. We don't want to tell them how to do things that they know how to do or know how to figure out properly. Because probably if they can figure it out, they're better at it than we are as architects. But what I want to have that kind of balance between adding value and, well, actually taking away from value, because I'm stepping on toes, things that other people could do better. Now, the reality is that what this balancing act is, it requires judgment. I can't give you a bunch of rules for how to figure out what the right amount of upfront architecture. It's going to depend a lot on the project. And what it's really going to depend on is the team, the people. And getting the right answer here, or something close to the right answer, really requires an understanding of the people that are involved as well. Because ultimately, architecture and development, well, really, they're not separate phases. They're not kind of separate. They're not even separate activities. They really go hand in hand. That upfront architecture is just a starting point, and that's why it should be kind of just enough and not too much. Because the architecture is something that is going to be refined. It's going to evolve through the development process. And it's an architecture that, this is not an official phrase, I made this up for this talk, is something that's emergent with intention. In other words, it's going to evolve, but it should be kind of directed evolution. It's going to be something that we're going to discover things and we're going to incorporate them. We're going to guide the evolution of the architecture itself. And most importantly, the architecture is something that both architects and developers, they're both involved in, they're both influencing, and they're making decisions about. And to do this, what we want to be able to do in our architecture is capture architectural concerns and not design concerns. And again, this requires judgment or balance, I guess. And again, this is something where I don't think there are hard and fast rules that you could say this is how you capture what's an architectural concern, what's a design concern. Well, frankly, it depends on what you're doing. It depends on the people. But one of the things that I found to be a really useful touchstone is if I, as an architect, I'm working with developers, software engineers, if we're having some healthy debate about who's stepping on whose toes, then we're on the right track. That's a good thing. And what we want to do, and both architects and developers will also debate about this, is document what's useful. Now, this is something that if you've ever looked at things like the Agile Manifesto, this should be apparent what I'm talking about. The Agile Manifesto says something, I'm not going to get the wording quite right, but I'm going to get it more or less right, that we value features over documentation. Again, I can't remember exactly the wording. But what it's saying is documentation is not bad. It's just documentation isn't valuable unto itself. Documentation can be valuable for what it enables. Well, that's what I want to accomplish in architecture as well. I want to document those aspects of architecture where that documentation is going to be useful. Now, here's one place where that actually really matters and may not be apparent to see at first. Things that I document about an architecture today, well, that documentation probably isn't terribly useful to designers right now or developers right now because, well, we can actually just have a talk about something and we can communicate those architectural decisions in things like a sprint plan. So why document? Well, the value in documentation is not what I'm going to do tomorrow, but it's somebody else is going to do 6 weeks from now or 6 months from now or a couple of years from now. And so part of what we want to think about is in capturing architectural concerns and document and how we capture it is what are people who are working on this product later going to need and how can we benefit from them? How can we benefit them? And so that leads to a couple of points, the last 2 points on the slide, these are very kind of mechanical things, but they're important. The tooling that we use to capture our architectural artifacts really matter. The architectural artifacts, diagrams, descriptions, whatever it happens to be, they need to be something that's accessible and usable for everybody who might be interested in them. And this is something that architects sometimes have to adjust their mindset around in organizations as we move from separate architecture and development practices into integrating them together. If I've got a bunch of tooling that is really accessible only to architects, I'm going to think of something like Sparks' Enterprise Architect, Sparks EA. Great tool, reasonably inexpensive. An organization could afford to give it to a lot of people. High learning curve, not something that you could just hand over to a software designer and have them get a lot of use out of it. So what do we do? Well, I don't have a specific answer. It's going to depend on the organization, but just keep in mind the things that we document as architectural artifacts really have to be something that's widely usable by everybody. We also have to should have documentation that's versionable, that I can kind of evolve with my product. Because again, the key point about, or a key point about the value of what we do in architecture is, yes, it's guiding what's being done today, but it's also helping inform what's going to be done well in the future. So let's start putting these ideas together and look at an approach to doing agile architecture. And I'm going to come back to one of the diagrams that I had before. And this is the basic structure of agile development in SAFe, and again, lots of other methods as well. We're going to assume that we start with an inception phase, and then we move through a number of increments. And in each of those increments, we're delivering software using sprints and kind of, actually we tend to sprint in inception as well, but where we have a process for kind of starting up and then gradually delivering value. So where does architecture play? Well, let's start looking at inception. So without trying to go into detail about what goes on in inception, because that's not really the point, what I'm going to argue is that for agile architecture, we want to produce a couple of things as part of the inception process. We want to develop a conceptual architecture and an initial solution architecture. And the reason that there are two of these things, and the reason that conceptual architecture looks like it's occurring earlier in inception, and that initial solution architecture occurs a little bit later, because it does. That conceptual architecture, that's something that as an architect, we sketch out the overall architecture of what we think the solution would be like at a really, really high level conceptual level. This doesn't require a lot of work. It doesn't require a lot of detailed analysis. It requires an understanding of the basic problem, an understanding of, a few things go into this. Specifically, things that go into this are a business case, or more generally, just our understanding of the intended business value of the solution. And what I've labeled here is epics. And different people will call these different things, but basically these are the really high level use cases that describe what a solution is intended to do. Now, I want to be clear, I'm not trying to get to detailed requirements or anything. What I'm trying to get as an architect is a good sense of, well, what it is that we're trying to build from a business point of view, and use that to create a conceptual architecture, a very, very high level description of the solution. Now, why is that conceptual architecture important? Well, it's important because it gives us that first sense of what's actually involved in the solution. What are the big picture components? How do they fit together? What are they responsible for at a really super high level? This might be as simple as 4 or 5 boxes with some descriptions and a few lines between them. It might be a few pages, half dozen diagrams. What it's not is some kind of really detailed description of what we think something is. And here's why. The role of the conceptual architecture is to help get through the inception process. It's to help people understand, is this project viable? What's going to be required for it? What other systems does it touch? What other kind of impacts might it have? The conceptual architecture is really there to help support the decision-making process. Okay, so why have I got another thing, this initial solution architecture? Well, out of the inception phase as an architect, I want to be able to create a rough solution architecture, high-level description of the overall system. Now, what's the difference between a conceptual architecture and that solution architecture? Detail. It's really all it is. The solution architecture actually should flow naturally from the conceptual architecture. But the solution architecture, we spent a little bit more time fleshing things out. How much detail should there be? Well, again, what we mentioned before, enough that it's an actionable framework, enough that it captures kind of the key architectural elements of the solution, not so much that it prescribes things for designers. In fact, it can be pretty roughly sketched out because, as we'll see, we're going to have opportunities to refine it. I was very deliberate in calling this the initial solution architecture because I want to make it clear that what we're not trying to do is produce that complete architecture for the system. This is not a one-time thing. This is just a starting point. And again, that initial solution architecture, it flows from the conceptual architecture. It's also driven by the release plan, or kind of whatever its equivalent is. What I'm particularly interested in the release plan is essentially, at some point during inception, we're going to settle on, at least at a very high level, what are the basic features or capabilities of the solution that we're creating? And in what chunks are they going to be released? It's useful to know those in developing that initial solution architecture because it helps us have some clarity around, well, have I actually taken everything into account? But it also helps us make decisions about where certain things is packaged, what order things are. And that will often affect the solution architecture. What do we do with it? It informs the team kickoff. Again, the team kickoff is not necessarily a particular ceremony, but it's some activity where we're going to be taking that initial solution architecture and using it when we're kicking off the development process, so that we transfer some of that knowledge about what's in that initial solution architecture and kind of get that into the team, give them that starting point. Now, what happens when we actually start software development? Well, our work as architects is not done. Inside an increment, we're going to be developing software, and an increment typically is a number of sprints. Typically, it's more than 3, but I didn't want a crowded graphic. And our involvement as architects is to work with development in the sprints. Now, exactly how deep that involvement is and how often, it's going to vary a lot in your team. I've done things where basically been embedded, and others where the architecture function is working with the kind of sprint planning and the sprint review. The basic thing that we want to accomplish with this, though, is a couple of things. As we're working with development, we're helping guide them. We're helping them interpret the architecture. We're helping them understand kind of what it means for them in that sprint. But we're also going to be aligning the architecture to what's discovered as we work. See, as we're actually developing the software, we're going to be discovering a whole bunch of things. We're going to be working on more detail. And what we're going to do with that is, at the end of each sprint, we're going to be aligning the architecture to what we've learned. And that's learnings that affect the architecture. We might update some artifacts. We'll identify some architectural concerns for the next sprint. And every so often, we'll actually update the solution architecture. And I guess this seems a little bit confusing. Wouldn't you just tweak the solution architecture as you go? Yeah. What I meant by update the solution architecture is once in a while, something will get to a point where we actually want to really drive a whole bunch of detail into the solution architecture, or kind of develop some other concept in there because we need it to support what's coming up. The key message here is that our involvement as architects with development is to walk hand in hand, work together. Again, depth and mechanism of that is going to vary by the team and the project. But the key thing that we're trying to accomplish is to absorb the things that are discovered during each sprint, during the learning that happens during the software development process, and bring those into the architecture and continuously refine the architecture. And there will be times, again, this is that update the solution architecture piece, where we'll run into something and say, oh, now we got to spend a little bit more effort actually kind of really working on an architectural solution to some problem that's come up. But the other thing that'll happen is we're not just working on the current sprint. As we're working, we're also preparing for the next sprint, or sorry, the next increment. Now remember what an increment is. It's essentially, think of it as a release, is the easiest way to describe it. So as we're working on the current increment, we're going to be getting ready for the next increment. We're going to be refining our definition of kind of what the product is supposed to do, that's epics. We're going to be refining that solution roadmap, kind of the path that we get there. And we're also going to be transferring our baselining, our architectural understanding of the solution for the next increment. And so a recommended practice is an architecture review at the end of an increment in preparation for the next. And what happens to that review? Well, we look at what we learned from an architectural point of view, but most important, we look at, with an understanding of what's in the next increment, what are the architectural considerations that need to be worked into development? And that's kind of it in a nutshell. I mean, there's a lot of detail, and the detail is going to be dependent on how individual teams want to work, and there's lots of templates you can look for this, but it's kind of a reasonable question to say, well, where's the magic here? Isn't there something special that we do as architects when architecture is agile that we wouldn't do if architecture was not agile? And the answer is not really. There's no special magic. We don't do anything different. We just do it kind of differently. There is no magician here. There's just a man behind the curtain doing kind of very mundane, normal stuff. What's interesting here is the magic isn't in what we do. It's when we do it. That we're making the architecture continuous through the life cycle. That it's not something we try to do all up front. It's kind of continuous. And the mechanism that I've described in the last few slides about integrating architectural activities into the software development process, well, that's the seemingly magical piece, because that's an odd concept for a lot of people. It's also, the magic comes from who we do it with. That architecture is a collaboration with the whole team. It's not something that ivory tower architects do by themselves. Now, I've described a specific way of doing things, and it's important that you adapt your approach to the problem at hand because one size really doesn't fit all circumstances. The bigger the system is, the longer the runway, the more effort you should put into your upfront architecture, the more thought goes into the overall framework. But sometimes you also want to adapt to the circumstances. There are cases where you're going to have a really precise set of stable requirements. And if you do more architecture up front. In fact, sometimes you may do all your architecture up front. I once worked on a system where it was a regulatory change to what was going on in a bank. Well, that actually was really easy to accomplish from an architectural point of view because we knew exactly what we needed to do. We did all of the architecture up front because the regulatory requirements were so precise. But often that doesn't really work. In a lot of cases, and frankly, the fun cases are places where you're doing a little bit of exploration. And I don't mean you're just building a system for the sake of having fun and exploring, but you're building a system where you don't necessarily understand the territory, the kind of map of where you're going to be, how it's going to work, what's going to fit together. And if you're in a situation like that, don't try as an architect, don't try to map territory you haven't seen yet. Just kind of a fun way of saying, don't try and do architecture for something you haven't really explored yet. Focus on emergent architecture. Now, I'm deliberately blending a couple terms here, the emergent design and intentional architecture, that we build the architecture as we go. I would never say just charge in without an initial architecture, but sometimes that initial architecture is really, really rough and broad. And there's a lot to discover because we don't really understand the problem space yet. And if that's the case, your architecture is going to emerge. And if that's the case, you should also be prepared to build throwaways because it's not going to be unusual to go down a path that as you discover things, you get out of the valley and over the hilltop and look at the territory beyond and you realize, oh, we really did something that needs to change. And that should be okay too. And it's certainly consistent with agile software development practices. But the most important thing is that we adapt your approach to the people that are part of the team. The practices really have to follow the people, the skills, the experience, and the goals, both business goals and personal goals of the people who are involved. Because ultimately, we're not just building a system, we're building the team, we're building the people who are building the system. And our practices have to adapt to that. And that's why throughout this, I've been trying to emphasize the idea that there are frameworks, there's lots of methodologies, but all of these are things that should be adapted to particular needs. Well, the thing that should really be pushing a lot of that adaptation is the people. And this is where, in many organizations, as we're starting to move from a kind of traditional architecture practice to a more agile-oriented architecture practice, the people aspect of adapting practices is really important because, frankly, change is hard. But this change is also really worthwhile. And that covers what I wanted to introduce about this kind of key points around agile architecture. And we have just a few minutes left. I want to open the floor for any questions or comments or discussion that anybody has. You can come off mute or just drop something into chat.
Good day, it's Corey from Newfoundland. The issue that we have is that sometimes we're deploying a cloud-like service, software as a service. For the next project, it's like a custom build. And the project after that, it could be for the most part, a commercial off-the-shelf traditional system. So our problem is with the projects, these different types of projects, adapting one type of methodology or tool set for for providing the architectural guidance becomes problematic.
Yep.
We at times struggle with knowing which artifacts we need. Um, that was the reason why I attended the session, was to try to decipher what, as we transform to start using more agile practices, including sprints and scrums and all these wonderful things related to agile and lean, that, we're kind of like lost in this shuffle or this movement from traditional waterfall to agile.
Hmm.
So my question would be, like, do we need to take each type of project individually, like you indicated in your presentation, or could we have certain models developed for how we would interact with teams, or because it's not always just developers. It may
Yep.
be like a configuration of a cloud software as a service or a platform as a service.
Hmm. And at least in my experience, those those different scenarios really are fundamentally different, and I think they should be approached differently. So I'll take a COTS package implementation as one extreme example. Um, at least in my experience, uh, when you're installing a package, I'll talk about SAP because I've done that before. You're going to work with a systems integrator. They're going to have a methodology. You'd better not try to mess with that uh, because you're only going to cause trouble, and it's you're going to end up imposing a lot of costs that don't give you any value. And so our role as architects in a COTS package implementation is a little bit different. The package is a black box. Essentially, someone else is responsible for implementing it. What's our concern as architects? Generally, it's the integrations with the other systems that it's, well, integrating with. And that's what we can focus on. What are the connections with other systems? How does that fit within our integration framework or existing integration strategy? Maybe we have kind of standard tooling. And our role as architects is to fit those things together. Now, that it also tends to be a package implementation tends to be much more well defined than software development, because we may not understand the details of what's going on inside the package, but to hook it up with other things to do integration is generally fairly well described, which means you can also do more of your upfront architecture. But what is it that we're architecting? Well, it generally is the things that are under our control, the interfaces. And if you've got a standard list of produce these 72 different architectural artifacts for everything that we do, probably a large number of those are not going to add value in that particular circumstance. So it should be absolutely perfectly okay to look at um, what actually adds value to us, and what should we document and what we shouldn't. Then again, if it's a package, it's going to be interfaces. I would say it's largely the same with software as a service. So something like Salesforce. So Salesforce is kind of similar in that there's a set of functionality out there. You're interfacing with it. It's a little different from a package implementation because you don't have an SI, or not in the same way. It's more configuration. And so your role as an architect again is around kind of the interfaces. Now there could be other aspects to it too. In both those cases, we could also be concerned about information. How do we get, for example, in Salesforce, uh, how do we connect the data in that system to our data warehouse or things like that? So those are other architectural concerns. But again, they should be things that, with a little bit of thought, that should be reasonably apparent. What are the places where architecture adds value? If you're building your own system, great, all bets are off. Then it's in a much more kind of classic architecture space where we want to think about what the architecture of the solution is. We want to think about how it would be built. We want to think about how the pieces all fit together. concerns that frankly don't add a lot of value to a package implementation or a SaaS implementation.
I think, yeah, you kind of like explained it fairly well. It's not necessarily the commonalities between all those types of deployments which add the most value. It could very well be the differences between,
Yes, yes.
right? Like,
Yeah,
because,
that's a good
you
way
know,
of.
you
I've
need,
never thought about it that way, but that's a really good way of thinking about it.
right, it's the deltas between the three that I would think would add most value. Like you said, integrations with COTS, configurations with cloud, say for example, I'm just using like three different examples,
Hmm.
and um, development or custom, like it would be, you know, it would be almost like configuration, integration, stuff like that. You know, like it
Hmm.
wouldn't be almost like the superset of all things
Right,
that,
right.
right?
Yes, it's the intersection, not the union.
Yeah,
Yeah.
like a right, exactly. It's a union. It's a like if you're looking at like Venn diagrams and the way to describe it, it would be when, you know, configuration and um, and configuration and say like I don't know, customization kind of intersect, you know, like or I should say like when COTS, I should say, and SAS intersect, the point of intersection is literally what you would need as artifacts or outputs for a custom.
Hmm.
So just
So
assume like you need to know more because the people that are going to be managing it and supporting it won't have these vendor relationships, right? And it's not a closed system for the most part, like you'll see in cloud or COTS. It was we need to know uh, more information to be able to better support this, like in a custom, but yet just say in this example on-premise type of deployment.
yes, so a complementary way of looking at this is I mean, it's the same thing as building on what you're saying. Think about what your organization's span of control is. If something is out of your control, there's no point in architecting it.
Yeah,
But if
exactly.
something is out of your control, eh, what you are probably interested in as an architect is what's on the boundary, what's the interface,
Right. Right.
and that's the difference between SaaS and COTS. In COTS, the application from an architectural point of view is kind of a black box. I shouldn't be concerned about how it works inside because I can't control that. I am interested in the interface where information passes back and forth.
Yeah.
But in COTS, I am also interested in infrastructure architecture because I'm running
Right.
it.
Right.
SaaS, I'm
Exactly.
not. Yeah,
Yeah. And that could be for any number of reasons. It could be
right.
for like performance, scalability, all
Hmm.
those different dimensions
Hmm.
that usually become challenges. You know, as like just say for example, underlying architecture, like the physical architecture changes. So you want to be
Right.
aware that, you know, like you want to be aware that this is running on a quad core or whatever, you know, CPU with, so many megs of RAM and stuff, just to keep track of like how did this, as we migrated from this to another type of a server or another type of chip architecture, how is it performing and scaling?
Right. And it's interesting you chose those things to talk about because those are the quality of service things, like
Right.
availability and performance, that are often very much the concern of architects.
Yeah. Well,
So yeah,
for me, it has always been that way, but sometimes where I work, it's lesser of a concern. Uh, but for me, it's always been a primary concern.
yeah, good, good. Thank you for the discussion. Anybody else? Okay, well, I appreciate people staying a little bit over time. Thank you. Again, the recording of this will be made available in follow-up, and I want to thank you for your time today. Thank you for your attention. It's been a pleasure, and I hope to run into you in a course or webinar in the future.